Well, I guess we have to speed it up. So I'm Yiannis, this is Evelyn. We are going to talk to you today about how good communication helps developer build good quality products. We are going again to talk about people, following Yorgos' talk.
Be in the light.
Yeah, okay, sorry. Okay. I'm in the light. So I'm gonna start then saying that at SIG we see there is a global challenge, and if you remember, Yorgos said that there is a dire need for software developers, and if you don't realize that, then you live under a rock, and I will emphasize to that. So if we look at the numbers, currently we have 12 million software developers, which on average they produce something like 120 billion lines of code, new lines of code every year. So we have a nice benchmark at our company that estimates that around a software developer produces around 10,000 lines of code every year, which means including analysis, design, testing, and documenting all those lines. I have to say that the number of developers is steady. So the number of developers that enter the profession is not increasing as fast as the lines of code. And imagine that from those 120 billion lines, we have to maintain 15% of them every year, excluding all the other lines of code that we have to maintain from previous years, also all this legacy. So there is a problem. We talk about digital transformation, we talk about several things, artificial intelligence, microservices, you name it. The point is how we make all those things more sustainable when we cannot keep up with the growth. And
that is a problem.
Yes, so you tell us about the
Yeah.
problem.
And the thing is, we have to prevent ourselves from going crazy altogether in a few years. So when I'm listening to clients and when I'm talking to colleagues, very often I hear things like, IT isn't living up to its promises, or the business is throwing all these insane requests at us and they actually don't know what we're doing here. So I hear a lot about here and there. And what I hear is that the problem is that we spend way too much money on our IT and that they are still not working properly. And that we really want faster delivery and cost reduction, and shorter time to market and excellent CI/CD pipelines. And what we need in order to get there, well, obviously we need more developers, but we also need microservices and DevOps and serverless architectures. But when I'm listening to this, I'm thinking that there's actually more to this problem, to the actual problem, because in the end, I believe that software development is a technical activity conducted by human beings. So we should not only focus on the technical side of things. And I believe that we mistake a lot of our organizational issues for technical issues. So that when we are talking about the systems and the technology, that we should also take into account the other side of the story, the more social things. And when we translate that into the logic of the previous slide, then you get something like this. That the actual problem that we're facing is that we don't listen to understand, but we listen to reply. And that what we actually want is the right people talking about the right things at the right time. And what we actually need is properly working feedback loops, value congruence, and clear knowledge networks. And if we know what's going on from a social perspective, then we can let that work for us instead of let it working against us. Because it's not really about the pretty and clever and crafty code, but it's about fast and effective communication. And if we know what social dynamics are affecting our architectures, are affecting our way of working and what we are producing, then we can benefit from that actually. So in this talk we will take a look at a few of the social dynamics that are affecting our architectures, and we will also take a look at the more technical side of things, and we will discuss how you can balance both. And one of the main things there is developer happiness.
Yes, so some years ago we were reflecting together with Evelyn that everybody talks about the software developers who are the fundamental element in digital transformation, and they are the guys who are implementing the digital vision of an organization. But who cares if these guys are happy, and who cares if these guys are given the right tools, the right training, and the proper empowerment in order to perform the work adequately. So we looked around and we found this very interesting academic research from Daniel Graciotti and his colleagues, and they have written a very nice paper which indicates the top 10 causes for software developer unhappiness. And the very interesting insight we got is about number 2 and number 3. I mean, number 1, of course, the main reason for making a software developer unhappy is the nature of the problem he has to solve. So the more difficult the problem, the more challenging it gets, but also it's more, let's say, frustrating. But the other two reasons are the time pressure from the business. So we want everything yesterday, and we cannot wait, and you don't have time, the client is waiting. And the third was the bad quality of the code base they are working. So imagine that if you have to solve a very difficult problem under time pressure, and then you start reading the code that most likely somebody else has written some months or even years ago, and you have to understand that it's complex, it's not easy to maintain. So that also makes you very unhappy. It was a very interesting insight for us, because that's what we do at SIG. We analyze code and we rate its quality. So we decided to extend this research and understand how we can improve code quality by also understanding the way developers work and how we can help them from an empowerment point of view. So we did a research together with O'Reilly Media, and we had more than, I think, 1,500 participants. There were mostly developers, and the first question is, who is accountable for software quality at your organization? So more than 75% of them, they said that the entire team, the software developers, are accountable for the quality of the software they deliver. But there is always a but. More than 50% of those respondents, they say that they don't have the right means to address this problem, to address this challenge, that they are accountable for the quality they deliver. So started digging more on this. We started asking whether they use any code quality tools, any tooling that will help them write better code. So again, more than 50%, they said that we don't use any tools. And by looking on the causes about that, we had some guys said, well, the current tooling doesn't support the language we use. There are too many false positives and we cannot follow up on them, so we just stopped using the tool. But more than 70% of those people, they said, we don't have budget at all, so we cannot use it. We don't have the means to acquire a proper code quality tool. And only an 11% said they had a budget. The rest, 20% or so, they said they're not sure if they have a budget or not. So we can say that more than 80% they don't have budget for this kind of activities, and that's a very interesting finding because companies demand from software developers to deliver good code, quality products, and on the other hand, they don't invest in making these people work in a better way. But one can ask, what do you mean good quality product? What do you mean about maintainable code? And how do you define this? So, first of all, imagine that you are, I mean, most of us here in this room, we are software developers. So imagine you have a requirement, then you have to accommodate it. You start reading the existing code, then you identify a part of code that most likely needs to be changed, but then you understand that it's way too complex and very difficult to understand. So what you do is you don't touch it because you don't want to break anything. So you just try to do some workarounds, some copy-paste, and create a separate file. Then inevitably the system you're working on, it grows in size and complexity because you're just copying bad practices actually. And then all of a sudden, you realize that you need more developers to maintain this system because it's not easy to address any new requirements and it's not easy to keep the lights on in this system. At SIG, we call it the vicious circle of unsustainable software development, and I guess many of us can recognize that, to some extent at least. And we start preaching about maintainable software, but many times, usually the managers, they're asking, why do I care if my software system is maintainable? I just want it to do whatever the business wants. But if you look on the economical part of the software development, then only 20% of the cost of a software system is during the initial phase of development. The rest, 80%, is on the support phase. So the better you work on the initial development, the better the work you do there, the more value you will be having during the support phase, because A, you can maintain your system and you can fix bugs quicker, and B, you can incorporate new functionality for the business in a cost-efficient way. And as a good colleague of us used to say, maintenance starts after lunch on the first day of the new development of a new project. So you started developing stuff in the morning, you went for lunch, you come back, and you have to continue working. So you have to revisit your code, you have to read what you've written, so in order to continue, and that's actual maintenance. Again, we had to convince typically project managers, right? Or CIOs or IT directors or people who haven't written any line of software the last 10 years or so. And we did a study. So we do rate the quality of a code in stars. So 1 star is very bad quality and 5 stars is really good quality. And we try to see if there is correlation between the quality of the code of a system and the time to market to implement an enhancement and the time needed to fix bugs. So we did a research combining open source systems and closed systems from our clients, and it appears that if you have a two-star system, it takes you 3 to 4 times more either to fix a bug or to implement a new requirement for and ship it to production. So we try to care then for this triangle, as we like to say it, to call it. It's the code quality in first place, so the code should be of the right quality. The product should be on the right quality, so not only the code should be written in the proper way, but the system should actually do what the business wants it to do. And then you try to keep your software developers happy. So that's a challenge to keep the balance among those 3 elements. And trust me, I've seen systems with good code quality and very happy developers, but not happy business. And that's an issue. So one thing that we try to do, and some people agree, some people do not agree, but we like doing it, is to measure software quality. So to measure the quality of the code of a given system in order to produce the stars. And for that, we use several metrics. I'm going to skip this slide because it's about the pitfalls for measurements. We don't have enough time. So I'm going to go directly to the way we see software development. So first of all, your code should be simple. It should be short. It should not be having copy-pastes, and the methods that you write should not be more than 4 per unit. So these are the unit level metrics, as we call them, and these are essential if in today's agile development and test-driven development, these are the things that are fundamental. So if you have a unit which is not complex, then it's easier to test and predict its behavior. And also, if you don't copy-paste code, then you don't have to repeat the same things when it comes to bug fixing or adding a new functionality. These numbers that you see there, we revisit them every year and we calibrate them. So in the past, for instance, the limit for a unit was less than 25 lines of code, but we see that software developers are improving. They try to write more maintainable software, so this threshold has come down to 15. Then there is the architecture, how you design the system, how big are your modules, how encapsulated are the classes and how components interact with each other, how many top-level components do you design. So these are things that we check on the code, and they give us a very good impression on how well is your system architected, and then Evelyn will show you some really interesting examples about software architectures and how well they've been implemented. And then it's your culture, it's the way of working. I mean, you should always write code that is covered by automated tests, And then you should always try to apply the 7 Boy Scout rules. I mean, try to leave whatever you touch in a better way than you found it. So these are the 3 things that we take into account. For the rating, we take into account the code and the architecture, the way of working. It doesn't contribute to the rating, but still it's an element that we do take into account when we assess the technical quality of a system. And all those things, they're very useful when you want to have clear communication, at least between the developers and the management, because having a rating, having a metric, having the stars as a way to communicate the quality of your work, it makes things more transparent, it makes them more clear, let's say, and it helps the team defining their own definition of done, as we say. But I guess now it's your turn, so...
Yes. So yeah, the technical side of things, of course, that's where it all starts, right? But we see a lot of projects in which the actual problem or the root cause problem has not a lot to do with the code itself. So social dynamics, they are everywhere, and they are especially present in our architecture. So I want to discuss the three of which I think are most important here. And these are just, we listed a few on this slide, but luckily we won't have to discuss all of them. We are just going over the 3 most important ones. And in my opinion, there are properly working feedback loops, value congruence, and knowledge networks. So we're going to start with, oh, no, we're not going to start with feedback loops. So first, some sort of an introduction. Because we are writing code for other human beings. We are not writing code for computers. We have to make sure that other people understand what we are writing, what we are doing. Because if you're the only one who understands a piece of code, then that won't really help your project. So that has a lot to do with Conway's law. And you probably are familiar with Conway's law. It says that the way that you architect your software mirrors the way your organization thinks. So meaning that if you want to improve your software architectures or your code base or your system, then you have to improve your organizational structures as well. Or at least you have to reflect on them and see how they are influencing or affecting your architectures. And if we understand that, then we can also understand a couple of other things that are going on. For example, the deviation that we very often see between plan and reality. When we talk to our clients and they show us the designed architecture, and then what we do is we look at the source code, we reverse engineer the design that's in there, and then we compare it to what's in front of us. And then we are discussing that. And this is not an uncommon situation. This is actually a real situation that we've seen. So when we ask our clients, well, where did this go wrong then? Then we get a lot of different answers. And the fact that the answers are different, that's kind of worrying. I mean, it's not a problem that you're deviating from a plan or that you make adjustments to your design, but not knowing what you're working on, that can be a bit problematic. And this is actually Conway's law in practice, because, well, if your architecture looks like this, then imagine what your organizational structures will look like. So what we actually need, and here are the 3 things that we are going to discuss, are strong feedback loops, a shared sense of reality, and clear knowledge networks. And if I say, do you want to improve your communication structures or your organizational structures? And of course, everyone was going to say, yay, I want to do that. But how do I do that? Because communication is kind of a vague concept. So feedback loops make it a bit more tangible. They make it a bit less vague, actually. And this is the most simple form of a feedback loop. There's a developer, there's a system, developer gives input, and then by hopefully means of automated testing, he gets some feedback from the system, and he or she can decide, well, I'm going to do this and this next. But this is too simple, right? This is not how our usual loops, what they look like. Because we have way more complex projects, there are more people involved, this is just not happening. So what happens when we add just one other person to this mix, for example, the architect, then you can get a situation like this. And this is a bit exaggerated, of course, but it's to make a point here. You have an architect designing an architecture in isolation, and then when he's done, he throws it over the fence and say, well, now go implement it. And then there is no feedback between the developers and the architect. So the developers start implementing, they start working on it, and they have no clue what the architect meant with some of his choices. Why did he make certain choices? Why are we doing this? And then the architect, after a while, looks at the implemented architecture and thinks, well, what were they thinking? Why did they do this? And that's not what you want, because if you translate this into a loop, a feedback loop, or if you try to do that, then you get something like this, and that's not a loop anymore. because the architect isn't getting any feedback nor from the developers and nor from the system. And this will have you ending up with a gap between plan and reality. So this is what you want to avoid. And there's one thing that makes it even more complex, and that is that we as humans, we have this very annoying tendency that we want to include as many people as possible in one loop. I mean, how many emails do you have in your inbox with people in CC of which you think, well, that wasn't really necessary? At least I have a lot of them. So usually we don't see feedback loops, but we see feedback chaos, as I like to call it. And this is not productive. I mean, you have no clue what's going on in here. You cannot tell who's in a sort of a loop with whom, or who needs to be in touch with whom, or who needs to be communicating with whom. So this is chaos. And well, this is not what we want. So a first reaction to this could be, okay, I need to structure this. I need to make tiny feedback loops out of this so that they're all closed and that they're all properly working. You could do that, but I think it will be very frustrating, and it will take a lot of time that you can spend on more productive things. So that's why I really like this visual, because it kind of says that we need to structure ourselves to some extent. We need to organize ourselves to some extent, and we need to get to a situation that is manageable and that's controllable. Because what this visual says is that actually flat organizations, they will fail. If there are too many communication lines, then it will get messy, it will get chaotic, you will end up with feedback chaos, and that won't get you anywhere. So you have to define some sort of a manageable situation, and that's where, for example, organizational charts come in, like how are our teams structured? Why are our teams structured like this? And who needs to be in a loop with whom? So you have to reflect on your structure, see what's going on, but you cannot overdo it, because that will leave less time for other valuable things that you need to be thinking about. I think we have a short intermezzo here from Yiannis with the difference between personal and tool-based feedback and a case study related to that. So I will give the floor to you for a bit.
Yep, thanks. Many times we've been asked by our clients, should I use automated tooling to check the quality of my code, or should we do some peer reviews and code reviews and then define the quality of the code that we write? Yeah, I think that this is a false dilemma. This is a false dichotomy. The good teams should combine the best of two worlds. Let's say, the speed and the way a tool gives you very fast feedback. It's even if you give it 200,000 lines of code or 500,000 lines of code, you will be having your results within minutes, and that also allows you for scalability. And on the other hand, and on top of that, it makes things more objective. So you get a very objective picture of the situation of your code base. On the other hand, the peer review is more project and context sensitive, so you understand probably why certain parts are complex or why certain duplication exists in your code. So you don't have to penalize everything, but then you selectively try to improve things. And on the other hand, the team, they can work on a specific piece of code and concretely try to improve it and then learn from that process. So we think that teams should combine code analysis tools with good code reviews. And we did an experiment. So we have a client in Greece. Some years ago, they started a new project with 30 developers. Nowadays, they have 100 developers. So when the project started, the quality of the code was really good. Everybody was really happy that the new project was starting greenfields, that they had this luxury to design their own standards and come with their own definition of done. But then the pressure from business started, so you see a very huge drop of the system's maintainability. I have to say here that the y-axis is the quality of the code. So initially it was more than 4 stars, then it dropped to 3 stars. On the x-axis is the dates, or the timeline. So we've been working for some time now with that team. At a certain moment, we realized that nobody is using our tooling, is not taking into account the measurements. The teams are not performing any code reviews. So we conducted several workshops And we work together with the teams. Each team, they have one person responsible for conducting the code review. And within weeks, when they start enforcing and combining the results of our tool with proper code reviews, the maintainability of the code is way better. And it's steady there because they try to keep the process and keep the discipline there. That is about my intermezzo. Then the proof that good code reviews with tooling automation can go hand in hand. Evelyn?
Yes, thank you. So we will get on to the second social dynamic that I wanted to discuss, which is value congruence, and that's just a fancy word that social scientists like to use, and it basically means that you have a shared sense of reality. So that you have a shared, that you're living in the same reality, that you know what you're doing and why you're doing it, and that also includes having shared standards and metrics and definitions of done. And research and our own experience with clients kind of proves that teams that have this shared sense of reality are way more productive than teams that don't. And we are all familiar with the anti-patterns of value congruence. We are either heading all in different directions and not really knowing what we're doing, or we are being stuck in meetings all day and not getting any real work done. And this is, of course, both not what we want. These are non-ideal situations. So that is why we need autonomous teams that are not too depending on each other and that can create their own shared sense of reality. And of course, autonomous teams, that's easier said than done. We could give a whole talk on creating autonomous teams. We're not going to do that. But that's something to keep in mind when you are thinking about this. And creating a shared sense of reality, well, one of the first things that you then have to consider is, are we going to organize our teams around business domains or technical domains? And both have advantages, but when it comes to creating that shared sense of reality, I think that's easier when you're organized around business domains. Because you're talking about business problems instead of talking about the solution right away in terms of technologies. So that will make the conversation between IT and the business also smoother, because you kind of are developing the same language because you are talking a language that you can both understand. So that's really important. And when you have a lot of people in these teams, then what kind of people do you need? And there is no blueprint for that, but there is this thing called T-shaped profiles. And that means that you can have in-depth knowledge and more broader knowledge on either technologies or business domains. And when you are creating autonomous teams and a shared sense of reality, then it might be beneficial to have teams, and I'm not saying individuals, but teams, that are oriented more towards the lefty for you. Sorry. Because if you have in-depth knowledge on business domains, then you will be able to define and formulate the problem a bit better, because you can take a bit more perspective. And that has a lot to do with how we make decisions. Because it's easy and it makes sense to go with what we already know. So if I'm an expert in PHP and we need a new application, then it makes sense to think, okay, PHP, because I know that, that's my expertise. But it doesn't mean that that's the right solution for the problem that we are facing at that point. So if you have in-depth knowledge about the business domain, if you can formulate the problem really clearly, then you can select the right solution for it. And that will help you in creating a better product and creating better, more quality code. So talking about the autonomous teams things, well, that's a talk in itself. It's a study in itself. Nick June is someone who is really good at that. He wrote a book about it, so if you want to get started on it, then I would recommend reading this book. And then we will get to the third and last thing, the last social dynamics, which is knowledge networks. Because there is a lot of knowledge in the teams that we're working on, in the projects that we are working on. But a lot of this knowledge is implicit. Some of it is explicit, but most of it lives in people, in their heads. And that doesn't have to be a problem, because, for example, if Yiannis is an expert on a topic and I have a problem with that, I just go to him, ask for his help, and then it will be solved. But what happens if Yiannis is just way too busy, or if he's leaving the company? Then we might have a problem, and he's taking his knowledge with him. So knowing how knowledge is distributed between teams and within an organization, that will help us a lot. Starting with the distinction between information and knowledge. Information, data, and facts, it's tangible, you can kind of grab it. And knowledge is putting that information into context, relating it to experiences, to knowledge, and to people. And that's harder. But of course, our projects that we're working on, they're all about knowledge. And to make it even more complex, there are two types of knowledge. Explicit knowledge and tacit knowledge, which basically means implicit knowledge. And the explicit knowledge is related to information, but with a bit more context, and then the tacit knowledge, which is the most part of what we are doing, lives in people and their practices. And that's not very easy to transfer, it's not easy to share, so let alone document it. And documentation is, well, not our hobby, as we just heard, but documenting knowledge, that's a completely different thing. So we have to somehow find a way to see how the knowledge is distributed within teams. Because if we know that, then we can, for example, identify bottlenecks. We can see how our teams are structured, who are in our teams, and we can see that, hey, maybe this one person from that team, there are a lot of lines towards him, but not only from his own team, but also from other teams. So could it be that this knowledge holds, that this person holds some sort of a knowledge monopoly that we need to fix, that we need to take care of? And that's very interesting and valuable information to have. And that's all cool and all, I know, but can we measure that? And this is where it gets really interesting, because yes, we can. And we are not going to do that based on some vague information or gut feeling, but the beauty of this is that you can actually do this with source code. You can get a lot of behavioral and social data from the source code, and we are not doing that. There are these underestimated gold mines that we should use way more often, and that's version control systems, source code, and ticketing systems. Because they contain so much information that we could use to improve our social structures and our communication structures. We can answer a lot of questions if we just look at these sources. And we are exploring this, we are working on this. And we started with asking ourselves, what would we like to know in our projects from a more social perspective? And what kind of data could we get out of this source code? And we are starting to visualize that. And this is one of the things that we are working on. Because the beauty of these underestimated gold mines is that they contain a time dimension. You can see who did what and when did he or she do it, in which technology. You can see the time dimension here. And for example, a project manager could say, hey, I thought that the project ended somewhere halfway. Why was there so many work done later on? I mean, these are really interesting questions you can answer. You can see that, for example, the developer 2, he's working, the colors, by the way, are the components that they're working on. Sorry, should have mentioned that before. And you can see, well, he has a lot of knowledge about the pink ones. But there are other developers who are not working at all on that component. And does that mean that they don't have this knowledge, or what does it mean? So you can actually tell a lot about how teams and individuals are organized looking at source code and version control. So we are, as I said, we are starting this. We are not experts on this yet, but we think this is very valuable, and we are exploring this and working on it. So if you want to know more about that, then we are happy to talk about that. But we listed some of the questions that you can answer by looking at version control and source code. And this is just what fitted on the slides. Because you can imagine in our brainstorm sessions and in the beginning of this project, we had a lot of questions. But these are just a few of them that will help you in improving your organizational structures. And this kind of marks the end, I think, of our presentation. So if there are any questions, then we are happy to answer them. Yeah. Right? Yeah. Okay. Yes. I see a hand. Yeah, you can shout. We will translate.
Thanks. I was wondering if there's any fundamental difference between working remote or locally in an office in regards to maintaining quality. Do you think that some things are more important in one case or the other, or something like that?
Did everyone hear the question? Okay. So from a social perspective, I think that it's really important to, working remotely, of course, you can do it and the same principles apply. But I think it's very important, and research also shows that you will have to be together physically at some point and regularly, not like every week, but you have to be together in the same room working on the same things in order to become a better team, because you will get to know each other better. And there are all these theories like social presence theory saying that you can also reach that through technology, but there's always a little part that you just have to be in the same room for. So it's necessary, yeah. But from a technical perspective, to maintain
from
quality?
a technical perspective, I would say that if the definition of done and the rules are pretty clear for the team, it makes it more imperative when you have remote developers, because these are the guys who are more difficult to reach and somehow manage. So essentially you need more processes in place, but all the essentials that we described here, like the guidelines for the unit level or for the architecture, they apply either you work on site or remotely. Yes, please.
Have you made any experiment or like anything? Do you know anything about the salaries? How do they affect, if they affect the quality of the code? I'm not talking about starting salaries, but how well is a person is paid throughout the years, like good persons evolving to better paid jobs?
No, but that's a very interesting subject.
It's an interesting idea.
Yes.
Yeah.
When we talk about developer happiness or developer unhappiness, we don't take salaries and working conditions into account. Mostly we focus on the practice, on the software development practice itself. But that's a very interesting angle. And by the way, I think that there are some studies from O'Reilly Media and from Slashdot, which is actually a Greek company that does market research analysis on development salaries and the status of developer nation. So if you go to their website, you might find some studies there. But I think also for us at SAG, it's a very interesting subject to touch upon. Thanks.
Thanks for the idea.
Yes.
Over the years, have you observed any significant differences in quality across application domains? Any differences that you can report?
Can I answer?
Sure.
Yeah, well, what we've seen throughout the years is that the teams are trying to improve their development processes. So slowly but steadily, we see improvements. We see more adoption of unit testing or continuous deployment or continuous integration or issue tracking systems or these kind of things. We see continuous adoption, not as spectacular or as drastic as we would like to see. On the other hand, we tend to see that systems written in technologies like Java or C#, they tend to be more maintainable because these languages actually they facilitate good and maintainable development, let's say. And these are the main trends that we see. But also, we notice that also in from UX frameworks like Angular or React, we see that the frameworks themselves, they try to cater now for more maintainability and for writing better code. So in general, we see the industry moving towards that direction, but not as fast as we wanted to see. Because at the end of the day, it's also a people's, it's human, it's very human-intensive activity. So it's not only the technology that helps you, but also it's a mind shift that needs to take place in order for teams to perform better.
Right.
I think we're done. Thank you very much, and thank you for your questions.